that was kind of this moment of epiphany for me. Because at the time I was working, on my radar program, and had an amazing software team where they had really turned around their software to deliver capability. But yet we weren't really, if you looked at the whole schedule, we really weren't any further ahead in delivering product. And it just happened that at the same time, I was reading the goal. And that's when I realized, and it's actually the very opening story that I write in my intro. It was that moment that I realized what we did. We had built all our efficiencies before the bottleneck. So all we had done was move the bottleneck. And because we hadn't focused on that shift, we still weren't able to deliver, the whole thing any faster, even though software was speeding up.
Hey everybody, welcome back to the podcast. I'm Bill.
And I'm Clarissa, and this is Control Freaks.
Exactly. We all that. See, we're not going to cut that. That's gonna be our intro. We love it.
One day we'll get it right, but today's not that day. So Bill and I.
Go ahead, Clarissa.
That we might get out. Bill and I are so excited to have Suzette Johnson and Robin Yeman here with us today. We'll get them to introduce themselves, but I want to start with the objective and what we want all of you to walk away with today. We want you to learn some ideas and approaches that, and learn from Robin and Suzette on the trials and tribulations that they've encountered and successes when they have tried to apply Agile, Lean, and DevOps to areas other than software development. So for anyone who's tried to have a conversation with someone outside of software development and talking Agile, Lean, DevOps, sometimes you get the response, and I know I've experienced this too, of, oh, that only works in software development, or from the audit perspective, oh, that only works in IT audits. So we want to dispel some of those myths, and that's what we want all of you to walk away with is a different understanding, a more open mindset as to where we might be able to apply these different ways of workings. And then what might set you up for success if you're driving some of those transformations as well. So Robin, Suzette, do you both want to take a couple minutes and introduce yourselves to the listeners?
Sure. My name is Robin Yeman, and really excited to be here. I have had the opportunity to have a pretty diverse career. I spent most of my time working at Lockheed Martin, which is a large defense contractor, about 28 years, building everything from submarines to satellites, so a whole range of capabilities. And I currently am working at Carnegie Mellon, the Software Engineering Institute. We're an FFRDC, and our goal is to help the government build capabilities, deliver capabilities at the speed of relevance.
That's awesome. Welcome.
Thanks.
Suzette?
Yeah. So I am Suzette Johnson. I started my career in the commercial space, actually for a tech startup in the late 1990s, which was pretty amazing opportunity. And with the surge of the whole internet boom at that time and e-commerce, it was a great place to be. Shortly thereafter, I came to work at Northrop Grumman, and I've been there ever since. By trade, my background is systems engineering, and very similar background as Robin, which is how we ended up getting connected. And my primary focus as an NG fellow here at Northrop is really continuing to drive lean and agile and DevOps practices across our company, and specifically in our space systems where we have the most significant cyber physical systems. It's a real exciting place to be right now with the emerging capabilities and growth in the space domain. So I thank you for this opportunity.
Well, we're both excited to have both of you, incredible backgrounds, and really excited to dig in.
So, quick question: would it be fair? Is this fair? So, correct me if I'm wrong. Are you recovering systems engineers and agile holics, or is it the other way around? How's this playing out?
I think I started as a developer, right? I'm a software engineer by trade, and for the longest time, I told Suzette this, for the longest time, people kept saying, yes, but you don't understand systems. I was like, that's it. So I decided to go get my PhD in systems engineering. I was like, I can't keep hearing this argument. So it's probably the other way around.
I
Nobody
like
can
that.
tell you don't understand anymore.
I mean,
Yep.
that's like the ultimate mic drop. You don't understand anything. Hold my beer. Let me get my PhD.
I know, right?
And it's interesting because it was a different experience for me. So my background, as I was saying, I started in systems engineering, and then we wanted to, back in 2005, deliver capabilities faster. So as the systems engineering management lead for this effort, it was my responsibility to figure out what should we do? What are the practices that will help us deliver capability faster? And I had a coworker that I just happened to meet, and we talked about this Agile thing, and I'm like, I think this is it. This is how we need to be building our system, and we just moved forward with it. And it was really from that systems engineering focus that we got started, because software kind of knew how to do it already, but how do we broaden it across our system?
I love this. This is what you two just went through. This was a beautiful message right there, and this is like why Clarissa and I are banding together, because I think a lot of people understand to do this, you have to understand the other side of the house. Robin, you went from software engineer to systems engineering. Suzette, systems engineering to the software side and the agile side. So at the end of the day, and I remember talking to a couple of people that are starting their own transformations, and they get to that point where I have to understand the other side, and they absolutely hate it. But I just before we get going, I just want to pull this out to the listeners. This right here, you want to understand why your stuff fails. Well, this is the first reason. This is the first way not to make it fail, to be able to legitimately put yourself in the other shoes. And I want to go somewhere with that. So your book, you recently just published a book, Industrial DevOps, here in October, which I've read through it. It is freaking phenomenal, by the way. Lots of stuff. We'll cover it today. But Industrial DevOps, what is industrial DevOps? What's this term mean?
So industrial DevOps, and I'll start, and then Robin, feel free to add to that. But what we were looking at is, how do we take all the goodness that we were seeing from the software community and apply it across the value stream to include not just software, but hardware and manufacturing and supply chain, and all the different areas that it takes to actually deliver a capability. But again, I want to highlight most significantly, it was really looking at and embracing the hardware community, because we were delivering software, but we found in the type of systems that we worked, you could deliver great software, but if the rest of the value stream wasn't with you, you still couldn't deliver. So we wanted to, again, take those practices from Lean and from Agile and DevOps and systems thinking and apply it in that cyber physical space.
So quick question.
go ahead.
So I don't have a tech background. I have an audit background. So I'm always asking I call them the foundational or elementary questions. Can you help someone who doesn't have a tech background understand what you mean by cyber physical? That's a new term for me.
So typically, cyber physical means a vehicle, right? A car is cyber physical. It has software, it has hardware, as electronics. So it's got multiple different aspects to create a system.
Okay,
Awesome.
So the emergence of, at the end of the day, if I say it a different word, it's just the emergence of software and hardware. A lot of people, people don't think about them. When you look at a car, like you said, Robin, you look at it as one thing, but when you really think about it, it is two separate things. There's hardware and there's software. And it sounds like, Suzette, as you're talking about what industrial DevOps is you can build the software as fast as you want, but you can't build the car any quicker until you start integrating these two. You got to make that whole system. And I think in your book, I love it because you talk about Goldratt's the goal in there, and some of the very introduction stuff, which I think is interesting. So let me ask this: as you guys were talking about, did the fact that you read the goal and knew about the goal and the theory of constraints in industrial DevOps in your projects, did that help at all with any other non-software people, like manufacturing engineers or anybody else like that, or were they still like, nope, sorry, this stuff's not for us?
I think that it depends, right? So for some people, absolutely, they got it right away. For others, I think even now we still meet with folks and they're like, and this software development thing. So I think that the goal and the way they put, the way Goldrad put it, which was, basically the analogy while he was having the Boy Scouts, walk and how that constraint just caused the problem for everybody. Like, it clicks. Everybody gets that. And it's the same thing in system development. How about you, Suzette?
Yeah, so I'm so glad you asked this question because that was kind of this moment of epiphany for me. Because at the time I was working, on this my radar program, and had an amazing software team where they had really turned around their software to deliver capability. But yet we weren't really, if you looked at the whole schedule, we really weren't any further ahead in delivering product. And it just happened that at the same time, I was reading the goal. And that's when I realized, and it's actually the very opening story that I write in my intro. It was that moment that I realized what we did. We had built all our efficiencies before the bottleneck. So all we had done was move the bottleneck. And because we hadn't focused on that shift, we still weren't able to deliver, the whole thing any faster, even though software was speeding up. And in some cases, I've seen where when that happens, when software is moving so fast, but the rest of your value stream isn't, then software just starts to sit kind of on the shelf. And when it's not used, and then defects are found so much later, and then the cost of fixing those defects kind of continues to rise. So
the WIP process. I have to be careful sometimes when I say this. I would find the goal. Every time I went in to go find a bottleneck, I'd call it the Herbie hunt. The Herbie hunt. So you have to be very careful when you say that. And if nobody's read the goal, they don't know what you're talking about. And you just
They're like what?
Yeah, like, we're doing what? Like, let me explain. And for folks that read it, a side note, you should read the goal, listeners, if you have not yet. But as Robin was talking about, when Suzette was talking about in the goal, the little Boy Scout, his name was Herbie. And it was basically how to pace the line. And Herbie was the slow Boy Scout. And he was at the very end, and the other Boy Scouts kept getting further and further ahead of him. So to keep everybody together, they put Herbie at the front. So Herbie paced it. And as Suzette was talking about with bottlenecks, Herbie was the bottleneck. So if you want to make the Boy Scouts go quicker, you focus on him. And the beautiful thing about this, what I love, is there can only ever be one bottleneck in your system at a time. Regardless of how many things you think are slow, you can only have one bottleneck, one thing that's pacing your system. So I'm going to stop geeking out on that one because I think everybody should love it. Anyways, so cyber physical. This is interesting because cyber physical is the emergence of software and hardware together. As you're talking about this, software is going quick. It was piling up. We're not getting a return on investment. This almost sounds like some stuff that's happening in the auditing world when Clarissa and I talk about it. Can you dig in more on how you guys are solving this cyber physical problem?
So I think you're exactly right. It is just like what Clarissa is dealing with, because one of the biggest things, at least in Suzette and my domain, is being able to get authority to operate, right? ATO. And actually within large government systems, ATO, authority to operate, is more expensive and takes longer than building the entire system itself. Right, so people don't actually realize the extreme expense, and it's because we don't begin with the end in mind, right? So I'm going to build a system for Clarissa, and I'm all done, and then she's going to go, but this and this will never go, which creates this huge rework cycle. So we do it all again. Beginning with the answer to the test question, right? So tagging up with Clarissa on the front end makes it so that I'm beginning with the things that I have to have done before it can be deployed. Otherwise, I can go as fast as I want. It still isn't making any difference to the user.
And so if I'm missing the part of the point here, point me in the right direction, but when you begin with the end in mind and you're figuring out kind of where do you want to go, a lot of that seems to be focused on the value. So you could do all these other things, but they're not valuable. You could be focusing on creating things, but if that's not focused on what's valuable to the end user or the end customer, then it's kind of a little pointless.
It's very close, but the difference is I could build something very valuable, but it may not be able to be certified and put into the customer space. So,
Okay.
for example, if I update flight software, but I haven't begun with what it's going to take to certify that flight software, I still can't give it to you. It's not that it's not valuable, it's that I didn't begin with the constraint. It's a little bit like cybersecurity. I could build systems that are, completely open to hackers. It may be valuable for about 5 minutes before they take it down. So I have to begin with, how do I make sure I don't have SQL injection, right? What are those controls?
And when I think about value, I think of it maybe a little bit differently too, is a system that is open to cyber attacks is not going to be valuable to me as an end
Right.
user because it's only going to work for a minute before all my data is stolen and everything is locked and I'm no longer able to use it. So
Yep.
that's, and it's interesting because we probably all define value differently. It's one of those, we all know what the word means, but like how we define it and what we see as value are challenging, which
Yeah.
creates a whole lot of challenges there. But so when we think about value that way of not just meeting one need, but meeting the continued needs, keeping an eye on what are all the value propositions and what are all the aspects of value that are important and starting with that in mind before you just start rolling with
Yes,
things.
you are exactly right. Yes.
Awesome.
I want to dig into this a little bit. So, systems engineering. I mean, this is also, it's based in physics. This is a really basic, physicists will pro this way. When you start in the end in mind, if I were to say you're actually starting with the constraints. So what's the end, but what are the constraints that we have to build to? And what's interesting I heard you say, Robin, is like, Clarissa, you think about control activities and controls. And I see this in software and hardware. Nobody really blueprints software, but people blueprint hardware. How many times can I go and find a spec on a hardware diagram about tolerances and basically my constraints? And I feel as we're getting to something here, that what's interesting in this, as you guys were solving things in the cyber physical world, was you were starting to think about applying, those same engineering principles, but what are those constraints? And Robin, you said CATO. So what are those constraints that I need the authority to operate to start with? And if we start there, or if I don't start there, no matter what I build, is going to be, and people don't like the word constraints, they don't like to be constrained, but the reality is you have to build the constraints. And because somebody like with Chris on the auditing side, like they, correct me if I'm wrong, Chris, but with controls and control activities, this is the strength of a good internal auditing team, is to help understand what the risks are and help communicate and help build those set of constraints such that that value can be delivered, not just to it, but can be delivered in a sort of an expeditious and a predictable way.
Mm-hmm. Absolutely. Good example, and it's a unique, working within secure environments can be somewhat unique. And, I had a system where we were building a multimodal biometric system, and I had experts in biometrics, right? So out in Utah, but they hadn't ever delivered into a closed system. We would call it a STIGD system in the government. And they kept delivering software, but my teams in Washington had to tear it all down and rebuild it because it would not work in a closed environment. And it's just because they didn't understand the constraint, right? They were building it the way they always could. And I know that that comes up all the time. Being able to understand what domain, the context that your work is going to be in. Otherwise, you can't actually deliver it.
I want to. Oh, go ahead, Robin. Or Suzette, sorry.
Yeah, I was just going to say, this ties into a couple of principles that we talk about with the multiple horizons of planning and the engagement of having everyone you need as part of that planning, so that you can continuously build in those constraints, work towards building against those constraints and building in the requirements that you need for security and auditing, and making sure that people that understand what those requirements are part of that team. Because I remember years ago building a system, and then, one day security comes to my area, and they give me this stack of security requirements and things that we have to make sure we're building into the system. But I was very fortunate, which is that this person, because I was like, I don't know what to do with all of this. But that security person, ironically, had an Agile background. This was over 15 years ago. So I just asked if he could just join my team for a few months to help us figure out how do we start building this in and actually build it in iteratively so that when it's time to release, we have built the requirements in. And oh, by the way, are there some of these requirements where we can actually automate or run scripts so that we don't have to keep manually testing against it? So that was a great experience. And like I said, it was just fortunate for me that that security person actually had the understanding of what we were trying to do. It was an amazing opportunity.
It was like shifting audit and security left before it was cool to do that.
Mm-hmm.
Well, let's dig down the hole. I wanna dig down the hole of multiple horizons planning. Before I go there, though, Robin, you said you used an acronym called STIG, Security Technology Implementation Guide, if I recall correctly, is the acronym. Clarissa, have you heard of STIGs before?
I did. I have.
You have?
So when we audited a certain type of technology, they leveraged the STIGs for configurations to make sure that they were secure configurations.
Yep,
yes,
you're always
I
ahead
do know
of the
that
game.
term.
You're already. What I love about that, though, like the STIG, because a lot of people that aren't in the DoD space have never heard of STIG, and so when you think about it, and I'll use the word control and control activities from the audit realm. All a STIG is a list of control and control activities for a specific piece of software, like a operating system, like Linux or something like that. Which it gets back to the automated governance aspect. And Suzette, as you're talking about some of these agility stuff, like STIGs are a great way to automate this, or the concept's there. So I wanted to highlight that one because as we go to multiple horizons of planning, like the ability, like I look at from the governance engineering side, the ability to codify this back into something that's automatable is key. And I think STIGs are a very key example of how you can automate it. But let's get into multiple planning horizons. And so I feel like, Clarissa, as we talk about bringing our sides of the house together, and Suzette, with the story you just told about some security, this is like the first probably one. I mean, all these 9 principles are key, but I feel like this is the first one to have to get over, because if you don't do this, you can't organize for flow, you can't do data decision driven. Like the other ones, I'd largely argue they don't systematically matter. But like, how did you all, like, can you give us like some stories, some horror stories, success stories? Like, how did you go through? And for the listeners here, they're going to ask it because they're going to go to their auditor. They're going to try to do what you did in their context. So how could you help them with your experience outside, of course, read the book? Do you got any quick stories, anything you could tell about the planning horizons and how to do it better, or how to do it?
So I'll start and then I'll pass it over to Suzette. But one of the things that I see pretty regularly, and it's not unique, but we have an aspiration to deliver a product, right? And we have a time, and basically we have one single fixed time. Well, we can't actually validate it. Now, many people in the Agile community will beat us up and they'll say, well, we only need to plan for 2 weeks. Well, that can be really difficult if you want to build a submarine or a radar. Like those are very big, long systems. Planning 2 weeks at a time means that we could probably lose the forest between the trees, right? So what we're saying is, yes, I need these short planning horizons. I also need to have the long one, right? So if I'm going to build a satellite, maybe I need a 3-year plan. What's the end? But I also need to further inform that plan. So typically in the waterfall space, I have a plan. I decided it when I knew the least amount of information, and now I'm going to beat everybody into submission or something like that. What we're saying is, actually, even in these, let's say 1 week, 2 week sprints, I'm getting empirical data, right? So we're moving to an empirical planning approach. If I plan in that 1 or 2 weeks to, let's say, easy widgets, complete 10 widgets, but I complete 7 and I do it another sprint, it's likely, because a typical quarter, which is where the government does a lot of rolling wave quarterly planning, has about 6 sprints in it. If I go 2 of those sprints and I'm 7 out of 10, it's likely that at the close of the quarter, I'm going to be 70% complete. Now, I can keep going, but there's this reality that things don't magically fix themselves, right? It doesn't just magically happen. So if I see it after just a couple of sprints, I have the opportunity to adjust, meaning I can adjust my scope. I could potentially adjust my resources. I could adjust my automation strategy. There's lots of levers that I can pull, and that will allow me to get to that predictable delivery. Or maybe I'm just way off plan and I will adjust the plan. Now, the customer may not be happy about it. They might not be at all happy about it, but they are much happier to learn a couple weeks or a couple months in that they're going to have to slip than they are when we get right up close and go, you know what? I thought we were going to be done, but we need another 10 months. Like that goes so much poorer.
Surprise.
Yeah, and to build off of all of that, what I was thinking, it's, Robin was talking, is some of this, the multiple horizons of planning, what it's addressing are two things. One is this scaling that we're dealing with, especially in cyber physical systems. And then the other is the experimentation and the feedback loops that we need for complex systems, right? So because we're scaling, we do have to think, you do have a time, like when you want to launch that system, like for real. And that launch date, you pretty much want to hit that target because there's a lot of resources that have to be scheduled when it's time to do a real launch. In addition, it's got to go well because there's safety and critical needs. And we want it to be successful. But that could be, some distance out. So what the multiple horizons of planning will do is, as Robin was describing, we'll be able to iterate along the way. But let's just say that launch is 18 months out, making something up. Well, along that 18 months, where will you have an MVP or something that you can actually test, where you can show some level of integrated capability? And we want to, then we can iterate towards that, then have that integrated demo, either virtual or ideally with some sort of prototype where we can actually get real feedback on are our assumptions about the system accurate? And how are we learning? Because we might make some adjustments then that we hadn't thought about if we didn't have that experiment to learn from. And then it goes into the next cycle and we can continuously improve it so that we're that much better off when it's time to launch and we have full confidence when that date arrives.
And so this is a different way of thinking and a different way of working than how these types of projects have historically been done. Is that a fair assumption? So,
yes.
Yeah.
They typically, like for example, my first project at Lockheed Martin was building the Seawolf sub. I spent 3 years just defining requirements. Right? It's exactly the wrong approach.
So when you started to apply these different ways of working and these different approaches, I'm going to guess there was a little bit of apprehension or a little bit of pushback, and it wasn't just everybody like, okay, yeah, let's just change what we've been doing forever and try this new thing. So how did you overcome those challenges and find success with experimenting with these different ways of working?
Well, we keep running into a new challenge, right? So I typically try to map it back to some of the practices that people have done before. So we like to think that everything's new, but actually, right, the theory of constraints has been around for a while. Little's law has been here for a while. There's a lot of actual information, and no matter what we call it, it's been here. So if I'm talking to a program manager, and I bring up things like story point estimating, and they're like, oh my God, this fluffy thing that you're doing. All I need to do is map it back to Delphi planning. Delphi planning's been around since the 40s, and it's been successful since the 40s. So applying a language that people are used to and mapping it to something that's in their context that's known starts to make it seem a little less risky. That way, the pieces that are novel, you can still push forward with, but they've got some comfort. This isn't, brand new. You're just making this up on the fly.
Yeah, and there's also looking at your sort of early innovators, the people that are kind of eager to try new things, and starting there. And then you can build off of those successes and have some evidence of, this is how they're doing it. These are the results we're seeing. But it's always interesting because I came out of an environment where I had an amazing government customer that I worked for. But he always thought was, if we don't the risk of not continuously improving and doing things better was the greater risk, not the risk of not changing. Because, he understood like things are always evolving around us and we have to continue to evolve with it. So we were a little bit more of the innovators where we were willing to take those risks because we understood how that was important in terms of continuously growing and building new capabilities. In some areas, it's continuously looking at their successes or whatever success that they've had, or kind of to Robin's point, some of that same language, where are they comfortable, and then building off of that. In some cases, a little slower than we might want, but to continuously, evolve and a continuous improvement mindset.
That is fantastic. And I want our listeners to, rewind that and listen to that again. And here's why. Because this is, for anyone who's been in software development, I know I've been to a lot of the DevOps Enterprise Summits and I've heard these stories primarily in the software technology development use cases. Everything that you said there is exactly what they would say as far as how to create that success. In my own experiences with applying agility and DevOps and lean principles to auditing, that's the same advice that I give to organizations as well. Align on a similar language, align on what's not changing or what's not brand new, and show here's where these things have been successful, even if it's not in this particular instance. Starting with those people who are very excited. I love how you said the early innovators, build momentum with them, share that, and it's contagious. And I love how you also said understanding the risk of not innovating. There was somebody gave a talk at a conference I was at earlier this year, and the title of it, really catchy title, Innovate or Die. It seemed a little harsh, but it drew me there, and I feel long term that might not be terrible advice.
Question, Suzette. Have you read The Tipping Point by Malcolm Gladwell by chance?
Yes, it's been a long time, but yes, I have read that. Yeah, for sure.
As you're talking through that, that's reminding me. Like, I think it was Malcolm Gladwell. I could be misquoting. It's like it only takes 7% of the population to create a tipping point. It's like, Clarissa, you're going in. It's like if you find there's probably more than 7% people of some organizations that are really interested in doing better in different things. And I loved how you just organize them. Just be a bottoms-up leader, organize them, and go to town.
Yeah, and if I can build off of that, because it's the whole crossing the chasm, right? Mm-hmm. And you have your innovators, your early adopters, and then you have this chasm into the early majority. And just an interesting story, because I started my career, right? And remember, I said I started even with tech startups, and when I came into where I am now, I started more with the very innovative group of people. So that's just what I was surrounded with. So we embraced innovation and change. But once upon a time, as things are starting to grow, starting to scale, you're reaching a much wider audience. There are people that, start wanting that evidence. And I joke with people, I'll never forget the day. I actually remember where I was. When someone came up and said, can you show me the case studies where this works? And I always tell people, I was just stunned for a moment, because I thought, it's a fair question. There's nothing wrong with the question at all. But I just paused, because innovators don't ask that question. You innovate. Mm-hmm. And I had never asked the question, show me where it's been successful before, because I always worked with a group that, we're going to do what we need to do, and we're going to be successful at it, regardless of anybody else's success. Study. Yes, absolutely. But so I had to think I have reflected on that conversation a lot, because first, like, why was I surprised by the question? So that was what caused me to do the research. And then understanding, what is it that I'm actually hearing? And that's when I realized we were actually starting to scale, and we were actually getting into that early majority. We were starting to cross the chasm, because as you grow in an organization, that is a very fair question to ask, because now you're going to start changing some of your policies and practices internally at scale. And you want to know kind of what is that track record and what is the ROI that we're receiving. So
that's beautiful. Like we got just a couple of minutes left here, so I would have quickly, like in 30 seconds, doubled down on that. Like that crossing the chasm. So for the listeners that don't understand what crossing chasm is, it's a book by Jeffrey Moore, and it's about how high tech products go into the market. And you have these early adopters, and you have innovators, and it crosses a chasm. And this chasm is what's referred to as the whole product offering. So Suzette, what you just talked about there, and I think this is what a lot of innovators and organizations forget. Like, you have to cross a chasm. As you're building a product, you're also building a full product offering, not just a piece of hardware or a software. And like that right there is beautiful. That proof, that case studies, this explanation, we'll just call that like internal support, if you want to think about it that way. Like that's what you have to build. And it's what a lot of people run into. Like, you can do some early wins, but it's easy to get stuff started. It's hard to keep it in the air and flying over time. And I love it. Sorry, I'm geeking out on this because you just hit such a key point there that I like. A lot of people don't think about it, and they don't. And like, this is Robin, starting with the end of the mine. If we can innovate, but we're going to have to cross this chasm. So at some point in time, we got to start answering those questions.
Yep.
Holy cow, this has been phenomenal. Clarissa, do you have any last questions for both Robin and or Suzette?
Any last advice for anyone either in cyber physical environments or auditing, or some use case that we haven't thought of yet? If you're applying Agile, Lean, DevOps principles to something, what would be the last piece of advice that each of you would give to our listeners?
Well, the big thing that I keep coming back to is many of these organizations have cyber initiatives. They have digital transformation initiatives. They've got model-based systems engineering initiatives. Now we've got artificial intelligence initiatives and cloud initiatives. And really, one of the key things that we think is we need to come together and use all the tools in our toolbox to be able to build these systems faster. So stop being so literal, come up just a level, and really look at the flow across all work. It doesn't matter the type. How do I optimize delivery from the time I have a need till I get it into the user's hands? And in that case, we want to make sure that we're really looking at the system level as opposed to each of the individual pieces.
Sounds
Awesome.
like a
Thank
systems
you,
engineer to me.
Yeah, I love that. And I guess in addition to that, right, as we're just in this amazing world right now, right, where all of this is coming together and the digital capabilities are just growing at such a fast rate. So kind of bringing all of these things together gives us such an amazing opportunity. But all of that also means that we need to be committed to that growth mindset and continuous improvement, and that what we did 30 years ago, 20 years ago, even 10 years ago, because I continuously rethink about how these things are being applied, because it will be constantly evolving, especially like Robin's talking about AI, right? That's going to change some of this of how we're doing things. So we need to keep an open mind and constantly think about, well, how do we embrace what we have today, continuously improve, and then embrace those new ideas tomorrow. So we never have it all figured out.
I think that is a key takeaway, regardless of what we're talking about. We never have it all figured out. So Robin, Suzette, thank you both so much for being on the show today. We can post some links of where people can find industrial DevOps. Thank you, Bill. So again, thank you both for being with us today. I'm Clarissa.
And I'm Bill. Be a freak, not a foe.
Woo-hoo!